this should be purple. Okay, so we've already discussed that if you substitute x equals 0, I get 0 over 0. So I can use L'Hopital's rule. Okay, so just be careful with chain rule, right? So here I get 3 cosine 3x minus 3. And then plus what? The 2 comes down, cancels, plus 9x. Wait. I made a mistake here. I wrote squared, but that was actually supposed to be a cube. So all y'all got the wrong answer. My bad. Yeah, with the square, you should end up getting some sort of, I guess, a vertical asymptote. Cube, square. Yeah, so you should end up essentially getting like a 1 over x cubed, but that was actually supposed to be a cube. So cross out all your work. So we get 27x squared over 2 for that derivative. And then down below we get 5x to the 4. Okay, now, even though I did give you the wrong exponent by mistake, the next step of the problem, all of you should have done the same thing anyway. So what did you do after this? So you did L'Hopital's rule. Obviously, your term over here is a little bit different if you worked it out because I gave you the wrong exponent by mistake. You would have a plus 9x there. But your next step is still the same. What did you do, Jacqueline? What did you do for this limit?
I did it again.
You did it again? Are you allowed to
Yeah.
use L'Hopital's rule a second time?
I think so.
Yeah, of course you can. So you just have to make sure that you justify it each time, right? At each step, you have to make sure, do I actually get 0 over 0, right? Because if you don't get 0 over 0 or infinity over infinity, can you use L'Hopital's rule? No, right? So I plug in 0 and I still get what? I get 3 minus 3 plus 0 over 0. So I still get 0 over 0 here. Remember, cosine of 0 is 1. So I use L'Hopital's rule a second time. And now this is where your work is going to diverge from mine because of that term that I gave you that was incorrect. So again, L'Hopital's rule, derivative of top and bottom. So I get negative 9 sine of 3x. And then plus 27x all over 20x cubed. Now you might have a 9 there, and then you would go off and determine it's a vertical asymptote, but actually I didn't mean for that to happen. So now you're kind of doing this live, right? So this is what you should have. What do you do next? Especially for those who are not on camera and don't usually participate. Take the derivative again. Do it again, right? Nishika, why can I do it again? Or anyone? Why can I do it again? We're just blindly doing L'Hopital's rule again. We're just going to keep on whittling this down until it's just a nub, right? It's still 0 over 0, right? Make sure you actually make that check. Okay, so we get now negative 27 cosine of 3x plus 27 all over 60x squared. What happens? You get 0 over 0 a third time. So I have to do L'Hopital's rule another time. So now I get here, let's see, 81 sine of 3x over 120x. What happens? I get 0 over 0 a fourth time or fifth time, whatever it is. 243 cosine 3x over 120. And then finally, do I get 0 over 0? Can I do another L'Hopital's rule? No. So I can just substitute and I get 243 over 120. Or 81 over 40, whatever you want to simplify that to. So is there any limit you can do to the number of L'Hopital's rules? No, there isn't. As long as you eventually get a limit. If you eventually actually got, oh, the limit doesn't exist and is not infinite, actually then all your work was for naught, right? Because remember the big caveat to L'Hopital's rule was as long as you actually do get a limit. If you don't get a limit ever, then then the original limit is not necessarily equal to it.